Hello everyone. Hello General Chemistry 2 students. We are going to start our lecture series. The first one will be about the intermolecular forces. What is this picture? Yes, the you'll see a picture with a group of students. They are holding their hands together. Can you think that you can easily take or pull out one of these kids out from the line? How about now? Mm, no one is holding their hands together. So, what do you think? Can you take someone out easily? Yes. You would think why I am talking about these things and the intermolecular forces. Hold your patience. Intermolecular forces. Here are the lesson objectives. First, we will understand the differences between the intermolecular and intramolecular forces. Second, we'll talk about the different types of intermolecular forces. Next, you will learn about the factors that affect the strength of intermolecular forces. After that, we will be able to identify the types of intermolecular forces for a given molecule. Also, we will able to rank the magnitude of the physical properties of molecules based on their strength of intermolecular forces. First, we need to understand the differences between intermolecular and intramolecular forces. What is an intramolecular force? We'll find intramolecular forces as like you may have heard about the covalent bonds or ionic bonds. They are actually falls under intramolecular forces. They are relatively strong. As an example, when you look at this hydrochloric molecule, the intramolecular bond, you will find that with inside the molecule, they are attaching the individual atoms together. So those type of forces are known as intramolecular forces. They are inside the molecule. They are relatively strong. As an example, the bond energy of a hydrochloric bond is measured around 430 kilojoules per mole. Okay, what is intermolecular force? Yes, now we'll find the intermolecular forces between the molecules. This is an intermolecular force. They are actually weaker than the intramolecular forces. As an example, I use the vaporization, the heat of vaporization, as the uh, as an indication of an intermolecular force. Hmm. Yes, you will ask me, why did you use the heat of vaporization just to indicate the strength of an intermolecular force? Because the intermolecular forces are responsible for uh, the phase changes. When a substance melts or boils, actually the intermolecular forces are going to be broken, not the intra. Only the forces between the molecules will be broken when a substance melts or boils or when a substance undergoes a phase change. A phase change. Also, they are responsible for that non-ideal behavior of gas. If we look at this, if it's an ideal, it must be a linear curve. But if when it is not non-ideal, it will have a curvy behavior. Who is responsible for that? Yes, the intermolecular forces. How strong these molecules are attaching or attracting together. And they are also responsible for the condensed matter or condensed states of the matter. And the intermolecular forces also determine the boiling points, the melting points of the substances, and actually they reflect the strength of the intermolecular forces. What? Wait, wait a minute. When we see a higher melting point or a boiling point, what does that mean? Yes, they'll have strong, very strong intermolecular forces. That is the relationship. We will talk about three different types of intermolecular forces. Dipole forces. We will also talk about the hydrogen bonds and the dipole forces. Next, the London forces, or they are known as dispersion forces. Finally, we'll talk about the iron dipole or anion induced dipole forces. We'll start our discussion with the intermolecular forces between the pure atoms and molecules in a pure substance. What is a van der Waals force? Yes, the van der Waals forces is a collective term that is can be used to collectively call or collectively uh, name the dipole-dipole interactions and the dispersion forces. Dipole-dipole, hydrogen forces, and dispersion forces. All three can be uh, generally uh, named as van der Waals forces. What is dipole-dipole forces? Dipole-dipole forces exhibit or they occur between a permanent dipoles. Therefore, we'll find the dipole-dipole forces only between the charged molecules or only between the polarized molecules. Only the polarized molecules. We'll find the interactions. They are polarized as a positive end and a negative end. So the forces, the attractions occur between oppositely charged polar ends. So they'll align in a way that the opposite charges are facing together and they should be close enough together to make a dipole-dipole force.